Hello everybody, and thank you for tuning in to Next Realm Studios. So today we have a tutorial actually about the differences between volatile images and buffered images in Java. We're going to be trying to do at least one tutorial a week, going over the different aspects of game design, in particular how they relate to our projects. In our projects we are using Java for reasons that we'll go into during a video or a separate live stream. But I want to go ahead and get a tutorial out about the differences and why they're important. So if you're looking up volatile image information for Java on the internet, you'll see people will oftentimes tell you to stick with buffered images, as the Java Virtual Machine, or JVM, will attempt to kind of keep a volatile image instead of a buffered image automatically. However, in the real world, that is not always the case. So what you can see in front of you, I know it is hard to look at, especially with compression on YouTube, but if you just look at the black space, you can see the frame on the left is moving a lot faster than the frame on the right. This program is identical, except for the fact that the frame on the left is using volatile images and the one on the right is using buffered images. So it could make it easier to look at if I had less objects on screen instead of just 10,000 bouncy balls, but having that many objects is what tends to show the difference, the speed difference between volatile and buffered images. And if you have a lot of particle effects or something on screen, you want every piece of performance you can get out of them. So this is a real-world example. Volatile images, when you do them manually, they are often faster than using buffered images and hoping that the JVM will automatically switch that over for you. So let's go ahead and get started into how to do a volatile image. Okay, so here's what we have here. For this purpose, I'm using a class called an image holder that is going to hold all of our volatile images. We're doing this because later we'll be using this class in our project to make changes to volatile images on the fly, which is one benefit of using volatile images, is you can make changes to the file much easier, and it's also stored on video memory when possible. Therefore, it has faster access to GPU if you're using hardware acceleration. But that is enough technical jargon for now. So how we actually do this, this is what everyone is probably here for. So this may seem like a lot of inputs that are not being used right now, and that's because I kind of gutted out this object, and I'm going to show you how to build it piece by piece. So first thing that we're going to need is we will need to be using buffered images. In our situation, there are multiple ways to do a volatile image. What we're going to be doing is we're going to be loading in a buffered image, saving that buffered image separately, and then actually painting that buffered image onto a volatile image that we make. And the volatile image is what we're going to be referencing whenever we're doing paint commands or edit commands. And then one issue with volatile images is they can become unloaded, and that's why they're referred to as volatile, because they can be deleted from memory. And we're using buffered images as a way to restore the volatile image without having to do image IO read 10,000 times whenever that happens. So that's what this validate image method is going to be later. But for now, what we're using, volatile image private, buffered image private, etc. So here's what we're going to do. We are passing in a path to the file. Easy enough. So here we come down. Here's where we're actually going to load the image for us. So I'm not going to type it out like line by line. I get annoyed whenever I'm watching a programming tutorial do that. So instead I have the working method saved over here, and I'm going to load it in chunk by chunk. So first off, we are going to have a try catch, but I'm going to add that in just a second. So we're going to go ahead. First thing we're going to do is we're going to make a file, and it's going to be the path. Our path is in images and testing, and then whatever we tell the path to be, and we're using PNGs. And so you're going to do a buffered image that is loading that file. So buffered image load equals image.io.file, which is FI. And then here's where it gets a little bit crazier. So we're then going to get a graphics environment from the virtual machine. And so our graphics environment GE equals get local graphics environment. This pulls whatever graphic capabilities that you have. Configuration is then how that is configured for this JVM. And so you'll need those in just a second because in order to make a volatile image, you have to get, here, I'll actually just show you. I'm pulling it in right now. Because you're going to call create compatible volatile image. The way that volatile images are processed, you have to have something that's compatible that allows it to be painting so quickly, whereas the buffered image, sometimes it has to adjust what image type it is every time before it paints the image. So when you're having 3,000 bouncy balls bouncing back and forth and it has to change the image every time before it draws a bouncy ball, that's why it gets kind of bad. So we're loading the volatile image. However, what we're doing is when we create that volatile image, it's going to be a blank canvas basically. We are getting the width and the height of the buffered image that we just loaded in. So we get the width, we get the height, so it's going to be the right size. And then transparency is going to be, well, whether or not this image supports transparency. So with transparency we have three options, which is bit mask, meaning either pixel is going to be entirely transparent or entirely opaque. Opaque meaning that there's going to be no transparency at all. It's just all going to be straight up opaque. And then translucent is anywhere in between. You can have half transparent pixels, any alpha values that you want. What we're using is we're using bit mask. Translucent can cause bottlenecks later on. So when possible, use as many images as you can with bit mask, and that allows us to keep the background transparent while keeping the foreground perfectly opaque. And that's the fastest way to do that. So next up we have to validate it. And that just makes sure that you can actually use this. So it attempts to restore since the last validation call. But so you don't necessarily need this right afterwards, after you first create it, but I like to put it in there because I got an error one time, and it was due because I was using dedicated graphics. It had to do with my dual GPU setup. So because I have integrated graphics on the laptop and then I have discrete graphics, and something about the switching back and forth is what threw it off. So that might not necessarily be a just me use case, but since it fixed it for me, I'm hoping it can fix it with other users, so I'm leaving that in there, even though a lot of people say it's not strictly necessary. And then we are actually going to have to create a graphics object, a 2D graphics object. So if you see, we're starting to use up all of these imports I said we're going to use up, and it's only going to get worse from here. So we're going to create 2D graphic objects because we're actually now going to paint on to, I'm loading it right now, we're going to paint onto the volatile image. So we're going to clear the image, we're going to set the background to black, and we're going to I can't think because I'm running on fumes here. So we're going to set the composite to whatever the source is. We're going to set the background to black, and we're going to clear the image of any garbage data that happens to be in it. And then we are actually just going to draw straight onto the volatile image. So what we're doing is, and this is where Java sometimes gets hard to follow, we're creating a graphics object, a graphics 2D object that is referencing our volatile image. And so G is now basically the canvas of which we are painting all of this stuff. So this is just prepping the volatile image / graphics environment because it is a 2D graphics environment, and we are drawing our volatile image, which is LOD if you remember from up here, to the image at 0, 0. So it's perfectly being drawn right onto the volatile image. Best practice, as always, is to dispose once you are done with your graphics object. Since we have painted onto volatile image, we can now just dispose of that graphics object, and then we do have to surround this with a try catch because we are reading a file, and I have messed up parentheses somewhere. It is there. What am I missing? Sometimes chasing down these brackets is the hardest part, especially when you're copying and pasting back and forth. Oh, I'm missing the try. That would be the reason. I promise, I've done this before. It's okay, I've had professors look up stuff on Stack Overflow during a lecture. So use Stack Overflow whenever you can if you're doing game design. You don't need to reinvent the wheel every time. But this is the use case this method fits our use case the best, because we are going to be drawing a lot of objects, individual tiles, everything. So once it is disposed, G is deleted, released back to garbage collection. IO exception in case the file doesn't exist or is the wrong format, and then we are just returning the volatile image once it's called. And so our volatile image, we're using this method here. We are saving, this is a little bit of a cheat, but I'm using this only for debugging right now. Our buffered image is created in here. I don't have a separate method for loading it. So that's the main two parts that I need to worry about right now. I'm trying to see if there's anything else that I need to paste back over before we give this a shot. I think that's it, actually, apart from validate. Although for our current, I'll show you how to do it, but for our current, what we're doing is not necessary. So how would you validate? The same way we load. We're going to graphics environment, graphics configuration. We're going to then validate that it's still going to work with whatever the configuration is. If the contents are lost, I'm printing out the image contents are lost, and then we are actually just going to reload it from the main path that I have saved when the method is first called. So with that, we can go ahead and run this. So here's my first test. So how I'm testing this is we're creating 3,000, they're originally going to be ships, and then I just turned them into bouncy balls. They're going to be 3,000 of these little objects that will actually just be bouncing back and forth. That is their whole purpose in life, is to create 3,000 bouncing balls. So I have it doing with the volatile image, which we can go ahead and run. Let me see if OBS can pick that up. Yes. OBS can pick that up. You can see, I know it's going to be hard to see with compression, but they are all moving pretty quick. But now, let's go ahead and switch over to using it as buffered images. This is how we've been testing the difference. So now we're using buffered images. Oh, when I'm recording, it makes it a little bit more obvious. But you can see, oh, can you see? No, you cannot see. Now you can see. Nope, that's the volatile ones. That's the buffered ones. You can see they're going a lot slower. The recording makes it a little bit more obvious than what I had before. But you can see, I'm still trying to get used to OBS. But you can see they are going a lot slower. And now I can put them side by side. Like that. So one on the right, buffered image, one on the left, volatile image. Just makes it a little bit easier to see. And that is one tip that I'll actually give when focusing on game design. Do stress tests. a lot of times you're not going to find out what's an issue until it's so far down the pipeline that it's going to be such a wreck to try and correct it. There's been a couple cases with that with our previous project, which was a throwaway prototype. That's the project that you can see the other videos on our channel. That's not going to be at all related to what we're working on now, but that was our throwaway prototype, messing around with the AI and just painting commands. Through that we learned that volatile images, once you start getting several thousand images on screen, which might sound like a lot, but for a larger scale, half strategy, half action game like we're working on, it happens pretty quick once you count all the tiles and effects. So stress tests early. Find out what works best for your use case. In our case, volatile images are working above and beyond better from buffered images. So you will see comments, there might even be comments on this video saying that buffered images get converted to volatile images. And that is true under some use cases, but when it comes down to the real world, it doesn't always work like that. It doesn't, the JVM, while it is good and very forgiving, it isn't all powerful. It can make mistakes, or it can simply, however you're referencing it, not know that that buffered image needs to be converted. So, in our case, using volatile images is a little bit more of a headache, but is going to have massive performance gains. OBS is actually making it a little bit harder to tell now that I'm looking at it. Buffered images always move about this slow, but volatile images move way, way faster. But even now, running OBS, you can see quite a difference. So please, in the comments, let us know what tutorial you want to see next, or what phases of the project you want to see next. We're going to have a link to our Patreon down below. If you want to see more tutorials, or if you want to see our projects progress, please consider donating. I know this is kind of a weird time in the world, but any donations you can make is definitely going to keep the lights running, and we're going to be able to bring you more content. If you have any specific questions in the comments, let me know. If it's a good question, I can actually make a video, or anyone else can make a video, kind of showcasing the answer. So until then, see you next time. Thanks so much for tuning in.